The experiment that I'm gonna conduct now is string in a glass tube. These are the things required. Since I don't have a glass tube, I'm using a 5 rupee pen. I've removed the refill and the top so that this becomes a tube. You can see right through it. So it's a tube. And for the weights, I am using pebbles from my fish tank. So these are the pebbles. And I'm using polythene sheets to wrap those pebbles. And for the string, I'm using thread, normal thread as a replacement. So this is what it looks like after we assembled this. So this is a tube, this is the thread, and these are the weights. So as you can see, I've wrapped 3 pebbles in this polythene cover, whereas 10 in this. So this is heavier, whereas this is lighter. I'm gonna prove that. So see this? So by this you know that this is heavier and this is lighter. So I'm gonna show that this lightweight is gonna lift these heavy weights up. So see the string. I'm just keeping a short length of string this side and I've held the tube. See that? You can see that, right? So now I'm gonna rotate the string so that this lightweight lifts this heavy weight up. I'm gonna show it. You see that? I'm gonna show it again. Lightweight, so less part of string here, and I'm gonna turn it. Sorry, I'm gonna turn it. See? Once again. See? So it does happen. So this is the magic of centrifugal force.
Hello sir, I am Ashyad Balaji and today I am going to show you a simple application of centrifugal force, and after that application we can know that how a centrifugal force actually acts on the body. Okay, for that we need a string and a small thing which can be tied to that string. Okay. I have taken a keychain and a thread to make it tight. Okay, first of all tie a small knot tightly. Yes. Now hold it like this. Okay, and if we move like this, see that the body moving in a circular path, and if I released it suddenly, look what it happens. See that it has moved in a tangential way. While it's moving in a circular path, if I release it, it will move in a tangential way. This is what a centrifugal.
Now I am going to do an experiment which is one of the application of centripetal force. Here we can observe one gum bottle and a plaster. As we know that a plaster cannot hold a gum bottle, but I can say that a plaster can hold a gum bottle but by rotating it. By rotating this plaster, this can hold the gum bottle by using the force called centripetal force.
Good evening, sir. This is Madhavan, and now I am going to show one of the basic example of centripetal force. Look, sir, this is a small pouch containing around 10 grams ball, and this is 100 grams thing. Now, I am going to show you how a 10 grams can easily lift a 100 grams thing. Have a look, sir. Look now, if we observe in this experiment, a 100 grams thing is easily be lifted by a 10 grams thing. Thank you.
Today I am going to explain some examples for centrifugal force. For this experiment, we need two glasses and two plastic balls. We have to stitch these two glasses with the gum, and we have to put these two balls in these glasses. We have to put a stick like this. Instead of balls, I kept some aluminium wrappers. So now we have to send the both wrappers to the ends of the glass. For this we need to roll the plastic glasses like this. See, the both wrappers are at the the both wrappers are at the ends of the glasses. It is said that the centrifugal force pushes the both wrappers at the ends of the glasses. This is my experiment. Thank you, sir.
Good evening, sir. I am Jayashree from JF4 batch. Now this is the example of centrifugal force where I have taken a balloon. In that I placed a nut. When I starts rotating, the nut inside the balloon also rotates and it is placed at bottom. When I start rotating, it is also rotating inside the balloon. And when I stop rotating also, for some time it will rotate in the balloon. It is moving up. And when I stop rotating, it's also rotate for some time. For some time it rotated. Thank you, sir.
I am using a pile of coins to demonstrate center of gravity experiment. As you can see, I've made the coin pile into a leaning one. I've arranged the coins so that the pile leans a little bit. Now I'm gonna add more coins to it and see what happens. This is a stable body. But if I add more mass to it, its center of gravity will shift. And sooner the body will not be rigid. I mean, it will not be stable and it will collapse. I'm adding some more coins to it. I've raised the center of gravity, but it is still rigid, which means the plumb line is still at the base. It didn't come out of the base. I'm gonna add some more. See, it collapsed, meaning the center of gravity shifted much more to the left, and the plumb line is out of the base of the coins. That's the reason the coin pile collapsed. So this is the application of center of gravity. Start.
This is application based on center of mass. The apparatus required are a bottle with water and a thread tied to it, and a matchsticks and a weight. Now take the book and place it here. Now take a matchstick and place it at the center of the book perfectly. Okay. Okay. Now take the bottle with water and hang the bottle to this matchstick. Okay. Now take another matchstick and keep this matchstick between these two threads in equilibrium position. Okay. Now take another matchstick. Okay, and the height is more. Now let us take somewhat downward and set. Again we start right. Okay. Let us somewhat move this stick frontward so that it will be balanced. Okay. Now take the matchstick and balance this matchstick here. So you should put somewhat still downward. Okay. Now balance this matchstick perfectly. Okay. Now slowly take the book. The sticks are balanced, and this is the application of center of mass. Thank you. Just let us taste.
The idea of demonstration of center of mass. Here we can find the 30 centimeter scale. We all know the center of mass for 30 centimeter rule lies at the mark 15 centimeter point. Let's find it out. Here the scale has 15 centimeter mark here. Let's balance it here. See, we can notice the rule is balancing. Let's change the mark. Let's keep it 16. We can find it's not in equilibrium position. Let's make it to be 14. It's not in equilibrium position. That means it's proved that the center of mass lies at the point 15 cm for the rule.